Hello everyone. This video I'm going to call Applied Rust. How to apply Rust to a specific domain. And I had an idea to either use AI or blockchain. And I've gone for blockchain. I think maybe there's more scope for future programming with blockchain, smart contracts in particular, than there is for AI stuff. I can see AI predominantly being, even with Rust, it'll be ML ops type stuff, which I don't find particularly interesting. So I'm going to, yeah. Let's look at Stellar anyway. So Stellar is a blockchain. It's a foundation. So um, I'm not going to go into the politics of blockchains and IPO, initial coin offerings and airdrops and all that stuff. If you don't know the difference between a security, a digital security and a digital commodity, a security and a digital commodity, then maybe do some reading about the difference between something like Bitcoin and something like Ethereum. Anyway, this is about Rust, so I won't go down that rabbit hole. What I've been learning and collating really, on my website Red and Green, I've done 5 articles now using Stellar, but it's been using Stellar, which is a blockchain. It's a blockchain just like Ethereum is a blockchain, Bitcoin is a blockchain, so on. I've been learning this from Stellar with the emphasis on learning more Rust and just learning Rust, not for its own sake, it's not just for tutorial hell, but actually how it's really applied. Now, there's many ways where you could go off on a specific domain specific area and look at Rust. Obviously, you've got embedded, you've got blockchain, you've got WASM. WASM, I think, is a particularly interesting use case for Rust and will be increasingly more useful. And it's nothing new. I'm talking as if it's just come out. But anyway, this is me looking at and showing you some of the things which I've picked up on and asked ChatGPT about. I've looked up source code for. I've made my own toy examples for. So even this, look, we've got wrapper. So that's how you can represent an enum with a specific, you can specify exactly how you want to store the enum in memory. So you can do wrapper U32, wrapper U8, and so on for anything numeric. So without wrapper, so it's hashtag, so it's an attribute, and it's wrapper U8. Without that, you'd be storing usize because it would be 0, 1, 2, 3 for the variance of the enum. So wrapper, that's one thing that I learned from looking at Stellar. If I had not looked at Stellar, I would not have learned about wrapper. So that's just one little small example, really. I have noticed a great deal of use of enums, and I think enums are probably something that coming from, say, a Python background. Enums are something which you may not use enough. I've been learning Rust for about about 2 years now, on and off, and enums are still something I probably don't use enough of. I'm getting quite I'm starting to understand them and when not to use them. That's half the problem. It's not actually the syntax. It's knowing when is a good use case to use an enum, for instance. You can use an enum and you can have an enum just with one variant. So again, it's one of the difficulties with coming from a background where it's something like Python is just the actual terminology. So the left-hand side of an option, what you might call an option in enum, is a variant. On the right hand side is a discriminant. So yeah, lots of words to learn when you start getting into the long grass with Rust, but it's worth it. So I've been picking apart a lot of the examples, and so let's just look at something really straightforward, not straightforward, but really early on, should we say. So what is this? This is, obviously it's written in JavaScript and all that, but it's a web, it's like Rust, it's a playground. So no standard. That's the very first thing you'll notice. And if you've looked at Rust being used with embedded, you'll be familiar with the no underscore stud. So it's basically just saying leave out all the standard libraries. Use Soroban SDK. So Soroban SDK is a Rust, or this one is an SDK for Rust to write smart contracts for the Stellar network. So Soroban is the smart contract side of things, which is built on top of the Stellar blockchain. So you've got the Stellar blockchain, then you've got Soroban smart with the smart contracts which run on the Stellar blockchain, and then we're using the Soroban SDK for Rust constant, and then we're creating what's called a symbol. So you can see here we've got env contract, contract import, symbol, symbol short log. And really the only way to get to know what these are is just to spend a few hours, days, weeks just writing this code from scratch really. I tend to do something every day when I'm learning it for about a week or so, and then revisit it maybe during the second week, revisit every 2 days, and then maybe once a week. A bit like backups, really. So here we've got a struct, got an impl, const. So it's all Rust. It's obviously stripped down Rust. So the memory, one of the key things is the heap is not used because it's running in WASM, which is running in basically when the code runs, it's running as bytecode in effectively what is like a small virtual machine, not an EVM, not an Ethereum virtual machine, by the way. So it's just sort of in a self-contained, so it's in its own little self-contained area of memory, and when it runs, it does whatever the function you're calling. So you write the code, you compile it. So let me just change, I only have to change one character here. So compile, what you're doing is you're compiling your Rust code into WASM. When the Rust code is compiled into WASM, you then deploy it. So you need to deploy it with a specific hash. Now hash is a public-private key pair that you will need to generate to do anything. This is all running on what's called testnet. Testnet is a sandbox, effectively, where you can replicate what you would be doing on mainnet. Mainnet is where you need to use real tokens that cost real money. So everything I'll be doing here is on testnet, so you can copy whatever I do, whatever you see me doing here. What has just happened? I've just compiled the code. You got this menu here. I don't need to go on about that. So increment, the function is called increment. It's public, so that's why it's appearing here to use. And the reason why it's appearing is because I've used contract impl there. Had I not used contract impl there, I'm not sure if it would still compile or not. We'll find out in a few seconds. But it's that which is the attribute which is making it publicly or callable. See, there you go. It's compiled, but there's no, this pane here, let me just close the other one. Yeah, this is where you see the public functions, no public functions. So by doing the contract impl, it then, and obviously making the function public there, is what makes the function callable when you want to invoke the contract. So you write your code, you compile it, you deploy it. So you deploy it, which is effectively in real life, you'll be putting it on the main net, on the main blockchain. Once it's on the main blockchain, you can then invoke it. To invoke it, you would then need to pass a lot of command line stuff and add on -- increment with a value, which is what this is emulating or simulating for you. And what I've written here gives you some memory. So see, it's 2 plus 3 equals 5. Why has it got memory? Because we're using env storage. Env is the self-contained container VM thing, which is running all the code when you call it, when you invoke it. So it's some new words to get to know. But as I say, what I'm more interested in is actually learning how to, or I'm trying to benefit from a lot of this code, which one of the nice things about it is it's not going off too deeply into a lot of the more complicated generics and traits that you quite often hit halfway through your sort of your first Rust book. So what we've got here is a contract which is doing increment, which is kind of what you just saw. This particular example is trying to do some authorization. If the user who's calling the contract is not the one that is meant to, then it will fail the authorization and it will just quit there. So here we're using data key counter, and then we're cloning the user. So the user is up here, which is an address. So an address is a SHA-256 hash of some of a key. And this is good. Again, this is good practice at using get, unwrap or default. And yeah, it's good, very good at helping you to get really familiar with using enums, become fluent with using enums. There's lots of example contracts here. They do get more complicated. They do get more kind of proprietary. You got custom types there. You can run this in Gitpod, but I'm finding it takes forever, so I'm not using Gitpod. The thing here, you've also got so you've got derived clone copy debug on this because you're doing some comparison here. State equals increment. Right, let's jump over to how I'm actually. So that's again, that's the examples on GitHub. On my red and green page, this is all that I've been researching and experimenting with. Yeah, one other thing is we've got bytes n. What are bytes n? So they're obviously not a Rust standard sort of primitive, but what they do is they let you specify how much memory to reserve in your. So basically, it's a fixed length bytes array. And here we're doing, let's just see, we're doing 32 bytes. So it's a fixed length array. And then this is how we're testing it. So we're saying it's a U8, 32 bytes. 32 lots of U8, so it's 32 bytes. So there's quite a bit of clone involved here. Because it's cloning things because we don't use the heap. It uses something called linear memory, which is just a contiguous block of memory. So again, it's just a different way of thinking about things, and it's just, it's always good to think of things come from different angles. So, and the naming conventions we've got. So you create your struct, you create an impl. When you want to test it, you've got this built in. So you've got the builder, or you've got the constructor that is available to you, which is the name of your struct followed by the word client, and then you can create a new one of those. So that allows you to do tests. So Soroban is a very stripped down version of Rust, but the tests, you can use full fat Rust to write all of your tests. So if you're thinking, oh, I don't want to just start writing smart contracts because it's not really going to help me learn Rust properly, that's not entirely true, because all of the tests you can write in using all of Rust. Fuzz testing. Anyway, stellar.org. Right, I'll just quickly jump over and we'll just look at what I've been doing. So this is on my server. So I'm starting to compile on the server now because um, it does make the fun kick in when you start compiling stuff. So let's just go to auths. So this is the file structure. You see you've got, so the first way to start a new project is, let me just come out of that. So Stellar contract build. You'll need to install Stellar, which, what? Yeah, sorry. Stellar contract init demo one. So there you go. And it's basically built me the framework or the boilerplate for demo one. Do tree. You can see what it's built. So it's built cargo toml. So we've got other thing to remember is you get two toml files. Potentially inside contracts, you can have multiple contracts. And it'll always build you a hello world. So the first thing you want to do if you're doing a proper project is go into contracts. So just clear that. And I'm just going to move hello world to demo one. Call it demo 1A. So if we go back into contracts, there is quite a lot of changing directories and stuff. So if you want to, if you're more used to doing VS Code, yeah, fill your boots. Demo 1A, and then I want to go into cargo because you always need to update your cargo file to match your demo 1A. Go back up to contracts level, Stellar contract build. You'll need to install Stellar in all the information on how to do that and kind of the curl, the bash stuff is all on the Stellar site. So you can see it's building 100, and then that's just to build the contract. And then when you deploy it, you can do a test as well. I'll show you the test next. So it's all using lib.rs. So you have a lib.rs and a test.rs to start with. One of the things I've been looking at is how contracts are actually structured. So you typically will have a contract.rs, you'll have a test.rs. What else? You'll have the lib.rs, contract.rs, the error.rs. Yeah, you typically have sort of 5 or 6 .rs files. And the lib is really just the entry point. And you can see this is running on a Linux server in, I think it's in Norway with WebDock, who, if you haven't noticed, I have managed to blag some small bit of server space with. So that's why I mentioned I'm very kind of them. And this is just it's a joy to work on. It's so easy and very reliable. And yeah, anyway, I'm not here to big up WebDock, even though they are very good. So then we do, and then you need to do your deploy. So you do Stellar contract. And then you want the source account, which we use Alice. I've already generated Alice. And then it wants the path to the WASM. The WASM is what was just created in the contract, and so on and so on. There's plenty of other tutorials that go into all that, but just from a Rust point of view, rather than kind of a Stellar or a crypto. I don't like the word crypto. It brings up so many. You just think of little young boys with beards pulling open mouth faces on thumbnails, and yeah. So if we go into src, you'll see we just got lib.rs and test.rs. So lib.rs is the very basic boilerplate. So you've got no stud, you just saw in Okashi.dev. You'll always need contracts because we're writing a smart contract, which is the struct. So that kind of gives it, that's the name of your contract. The impl will obviously have the same name, but you just use the attribute contract impl with that. And that's what makes it invocable. So like you saw in Okashi, when I wanted to do the increment, it didn't show up, but then it did once I added this line. So without it and with it. Then Vec. Vec is a Soroban. So Soroban is the smart contract SDK. So it's a Vec which is particular, or it's of type Soroban SDK Vec. We've got EMV. EMV is basically the VM that everything's running in. So it's the self-contained environment that all of your bytecode will run inside of. String is a Soroban type of string because Soroban doesn't use the heap. So it's linear memory. So even if you don't want to learn about crypto, you don't want to learn about Stellar, you really don't like it or want to have anything to do with it, you can at least learn about linear memory. You can learn about using enums. You can learn about working with borrows in Vex. Mod. You can learn about doing tests. So that's there. If we do cargo T, so now it's doing 187 because it's compiling some more stuff. This is why I'm doing it on a server and not on my laptop. My laptop, the fan was just going crazy and got annoying and it got hot and so on. There you can see it's running. You can see it's got the ED25419, the elliptic curve stuff. You've got hex, you've got SHA, SERDE, hex, elliptic curve, Soroban, Stellar. So Stellar is basically the engine underneath all of the Soroban stuff. And when you run the tests, it's just cargo space T. So nothing different than an ordinary Rust project. And my next task is to really actually build a useful smart contract. If anybody's got any advice, I'd be very interested. I've gone on Discord. Probably that's a bit beyond me at the moment, but I just want to get going with actually writing some smart contracts. I'm looking at doing stuff with time locks and also doing stuff with bond. So bond is where you can mint some, or you can create some tokens as the admin, and then people buy the tokens over time. And gradually, as the time gets nearer to the end of the bond maturity, then the amount that people get back changes. And you can have an admin, you can have a user, you can have time locks and so on. So there you see it's just one test passed. So I think I'm probably going to leave it there because I've either bored you or I've given you some food for thought. I didn't mean to make this video this long, but just to summarize, you've got Okashi, which is probably a great place just to get started. And I really would just say just start from scratch. So there's no smoke and mirrors here. I'm not looking at another screen because I haven't got one at the moment. You'll probably work that out from the mistakes I make, but just get familiar with writing stuff from scratch, and then use Soroban SDK underscore SDK, and then you want contract impl env with a capital, string back, and you'll get to know whether it's uppercase or lowercase, etc., because whether it's a struct or an enum, etc. And then just you want your contract. I'm not going to write the whole thing here because I'd probably make some errors and it would turn into a really boring video. But then what are we calling it? Increment is kind of my go-to one. So public struct increment. And this is a good case of where you just use a struct just for a name. So basically it's like if you were in Python world, it would be just creating your class name. And contract import is all your logic. So again, then you would do import, increment. There's no autocomplete on here, which is probably a good thing actually, because it forces you to actually type stuff and know it from scratch. So then you do pub. So you need the pub to make the function viewable, and then I'd call it increment the lowercase, and then you pass in env, which is of type env, and then incur, which is my variable name, which can be of type u32 because that's still valid in there. And yeah, and then you just do kind of env dot store. With it very quickly, you'll get used to using env.storage.instance. So you're just getting you're retrieving information from within your own smart contract because it's effectively self-contained. And then eventually you'll get on to doing smart contracts that reference other smart contracts, and it uses the hash, or uses hashes for that, for referencing. So then you can do like set, you can do get, you can do log, which is a macro. Then you can add a constant up here. So typically you'd have a const, which would be, in the example, would be there, which would be count, which would be, I always do symbol. So this is effectively the key that you then attach some data, some values to. So symbol. And then you do symbol underscore short, which is again as a macro, and then you just put count. And just remember, if you're using symbol short, I think it allows you 9 characters. So the symbol is the type, and then symbol short is the macro. So something like that. And again, I could just undo all this probably, and it would just take you back to what we had to start with, which was actually there we go. So what I just typed wasn't far off that, was it? That needs to go there. I've got it quite big, so it's just wrapping around a bit at the moment. But and there you can see it's mutable. You still need to make things mutable. When you log, you still need like the curly braces to show values. You'll get very used to using tuples and I'm deconstructing them. So yeah, I hope this has actually just given you some motivation and just hopefully shown an insight into using something which is domain specific. But my big fear of being too domain specific is it backs me into a corner, and then one day everything I know is not quite so useful anymore. But with this, the big advantage of this really is that when you do the tests are pure Rust. And just this is good practice for thinking about linear memory, stack memory. You don't really use a heap. There is a few sort of clunky workarounds with allocate and stuff, but that's really a bit off on a tangent. So yeah, let me know if this is interesting. I'm planning on, to be honest, my next video may just be me slightly modifying one of the bond or time lock contracts out there. If you'd like, I can deploy it. Again, that's not really Rust specific. That's more specific to Stellar, the Stellar blockchain. But if it helps, I can do that. Otherwise, I will keep going with this, see what I can invent. I'm also thinking how to link this with something useful, such as yeah, AI or a database. Or web scraping or an API, or who knows. Any suggestions? Let me have these suggestions in the comments. And yeah, good luck with your Rust code. Happy coding. Cheers.